All right, so now we're ready to actually start modeling our robot here. And as we model this robot, we're going to find that using spheres is going to be kind of a common thing for making pieces connect together. Even if we're just using little pieces of a sphere, we're going to be using them relatively frequently. And in order to do that, we could go back and measure each thing every time that we make it in order to get things to align perfectly. But what I'm going to do here is create a series of spheres with different subdivision levels. So, in other words, I'm going to start here by just creating a single sphere. And you can see right now my sides are at 16. That's going to be a common one that we'll use. So I'm going to set one here with 16 sides. And I'm going to get it relatively close here. I know I'm going to convert this to p-subs, so I'm not going to spend a whole lot of time getting this really, really exact because the p-subs will be scaled slightly differently anyway. So, but I do want to make sure that my x and my z measurements are the same because I want that to be the same all the way around in this direction. And then the y will obviously be a little bit different because of the way that the poles work on this kind of a sphere. So with 16 sides and 12 segments, let's go ahead and unsubdivide that and then press Shift-Tab to put it into p-subs. And now we'll go ahead and make those little corrections that we had made previously. Let's go back here and check. Yeah, it looks like it's a little bit wide. So let's start here just by scaling it uniformly down just a tiny, tiny bit. Oops. And actually, we might be close enough that we might not be able to get that scale down. So we'll call that good there. Then let's go ahead and check on the individual edge loops here. So let's start. In this case, we'll start up at the top, and we'll find that loop here. There we go. And we will scale that out with the planar handles till we get that nicely aligned. And then we'll move down to the next loop. And again, scale it. Make sure you can reach the planar handle there. There we go. So that one's scaled now perfectly. And looks like we've only got really one more left to go here. So let's go ahead and scale that one. And if you need to give yourself more screen space for a moment, it's not a bad idea. That way you can zoom in a little bit farther and get a little bit more precision on these. So that looks like that will do that one there. All right, so let's take a quick look around, make sure everything is looking aligned. I've got the same background guides. I've just renamed the layer guides over there. And I'm using that to check on this, and everything looks pretty good there. And let's check the top view also, which looks pretty good too. All right, so there we go. Now that's ready. So what I'm going to go ahead and do here, and I'll pause the video and then come back when it's ready, is create another version with 24 sides, another version with 12 sides, and that way we can have several different versions that we can draw from. Now I'm doing all of these with a 1 meter diameter or a 500 millimeter radius because that's going to be a really easy size to scale in increments. If we need something that's 250 millimeters in diameter, then we can simply scale this one down to 50 or to 25%, and we'll get that end result. If we need one that's larger, that's 1.6 meters in diameter, then we can just scale it 160% and get the right proportions. Okay, so let's go ahead. I'll pause the video, and we'll come back, and I'll show you the other ones ready to go into the rest of the model. All right, so here is the first one that we created, that 16-sided one. Here's another one with 12 sides, so you can see 3 segments on each quarter of this. Then there is another one here with 24 sides, so that one's got 6 on each quadrant. And then I went ahead and made one with 8 sides. So this one, you have to be really careful with dealing with this low an actual poly count because it tends to pull away more, especially in places here like the top. You can see that pulls away more, but pulling this up will cause lots of other problems. This one is one that doesn't work super well here at the poles, but if you're going to be bridging it to other geometry and you're only needing, say, that much geometry to go into something, then this works very well, and will also keep your polygon count and good polyflow when bridging onto other sections of the model. So we went ahead and also made the 8-sided one. Now I'm also going to go ahead and just take each one of these and rename them. So name it 12. Oops, this one's 16 side. 16 side. And this one is our 12-sided one. 12 side. And this one is the 24 side. And this one is the 8 side. So this is the ultra low polygon one, just for good polyflow. Now one thing to note is that the higher the polygon count here, the better the sphere does retaining its shape. So if you're going to have something that doesn't need to bridge into other pieces of geometry, use a higher polygon count. For some pieces here where I'm going to have almost an entire sphere, I'll probably even increase above this. I'll keep the 24, but perhaps increase the 12 sides here up to 16 or even maybe 24 around there, depending on how much subdivision you need to keep a good sphere. And if you don't need to bridge it to other parts of geometry except for maybe at the poles or something like that, then you can go with a higher polygon count, and that actually even won't adversely affect render time because you'll be able to use a lower subdivision level. You can see that my 16 side and my 12 side are at level 3. My 24 side I could probably bring down to level 2 and it's still going to look pretty good. And my 8 side has to be all the way at level 4 in order to get a relatively decent read. So that's just something to keep in mind. Now you can do like I've done here, and you can put these together. You can even group them, and let's call that sphere templates. And then the other option that you have is also taking these and saving them as presets. Make sure that they're created at the origin. Make sure that you've got them nice and symmetrical before you do so. But saving these then as presets will give you some other nice things to draw from, not only in this specific model file, but also if you're building other models where you can have similar things. Again, remember that was the other reason why we created this as a really kind of uniform size, the 1 meter diameter. That allows us to scale it very easily to other sizes without one, without a lot of math, and two, without a lot of actual tweaking. You can do it right in the viewport very quickly. Now, one thing to note here, and this is going to apply to two things, is that if you're to do something like, let's see here, let's bring up our 8-sided one. This will be the most obvious example. I'm going to hide my guides, and then I'm going to go to View and turn on the Dimensions tool. You notice this is actually going to tell me that my sphere is 1.1344 millimeters wide and 1.022 high. Now, that's because this is reading the actual vertex data. This isn't reading the subdivision surface model, and it can't do that. This will also then apply to using the snaps and precision, using something like absolute scaling. So you can't use that in order to get this to be the right size. It's just going to mess everything up. So your best way is, again, to eyeball this, and we can see this really obviously if, let's see, if I were to take this exact same sphere now and go to, let's see, geometry and freeze, and I'm going to freeze the subdivisions. Now you can see how close we've actually gotten at 995, 998. It's gotten much, much closer to the actual size of the sphere. So just remember that you don't want to use those kind of automated ways of getting specific scales. It will throw off your model, and it will make it harder to work in these P-subs. Okay, so in the next video, we will start building the body of the robot and start attaching in some of our sphere pieces that we've got here. Thanks, and see you in the next video.